Alright everybody, welcome back. In this video we're going to be talking about information from section 10.2 of AP Calculus BC, working with geometric series. And so we start here with a definition of what a geometric series is. It's probably a definition you've seen before, but a geometric series is a series that we create by deriving each term by multiplying the preceding term by the same number r. Okay? It's very easy. We talked in section 10.1 about how difficult it can be deciding what the value is that a convergent series sums to. With geometric series, that's actually one of the few cases where it's super simple for us to find the actual value that a geometric series converges to once we know that it converges. So let's take a look at some series here so that we, kind of have an intuitive idea of what's geometric and what's not. These are created by multiplying the preceding number by the same number r. So if you look at this first or example of geometric series here, we take the first term and multiply by 1/3. That gives us the second term. We multiply by 1/3 again. That gives us the next term. We multiply by 1/3 again. That gives us the next term. So we have to be multiplying by the same value over and over to get the successive terms. This second one here is a geometric series. We're going to multiply by -1/2 to go from one term to the next. 8 times -1/2 gives me -4. -4 times -1/2 gives me +2, so on and so forth. We're multiplying by -1/2 as we get each additional term in that series. Oh, I forgot my ellipsis there. And the same thing in this last one. We're multiplying by 2 as we go from one term to the next. By the way, a little tip, if you're stuck and having difficulty figuring out what the r value is, the real easy way to do that is to just take the second term and divide it by the first term. And so if this is a geometric series, the common ratio is 2, and so that's what I need to be multiplying by to get from one term to the next. All right. This next one, not geometric. This is what we call an arithmetic series. I multiply by 2 to go from the first term to the next, but then I multiply by 3/2 to get to the next term. So I'm not multiplying by the same r value as I go from one term to the next, which makes that not geometric. You will notice in this one I'm adding the same value as I go from one term to the next. This next one, not geometric. I multiply by, let's see, -6/8 or -3/4 to get the second term from the first term. But then when I multiply this term by -3/4, I do not get 4. So that's not geometric. And here, the same thing. I multiply by 1/2 to get the next term, but 1/2 times 1/2 doesn't give me the third term in the series. And so this series is not geometric. This is actually what we call the harmonic series. And we're going to talk about that even more in the future. All right. So here's our boxed info about geometric series. A geometric series is a series of the form a plus ar plus ar squared plus ar cubed. Remember, we talked about how we generate it by just multiplying each term by r to get the next term, and so on and so forth. And that is this series right here. I'm missing an ellipsis and an equal sign here. I don't know. I think something got shifted in my text maybe there, and some things got covered up with the image. This series converges if the absolute value of r is less than 1, and it diverges if the absolute value of r is greater than or equal to 1. So, last lesson we talked about convergence and divergence by using limits of the partial sums of a series. Once we've identified that a series is geometric, we don't need to try to use the partial sums to determine if it converges or diverges. We can just identify the value of r, and if r is between -1 and 1, this series will converge. Otherwise, it diverges. If the series does converge, if we know that the absolute value of r is less than 1, we can calculate the sum of the series by using this formula. S equals a over 1 minus r. All right? All right. For geometric series, this interval from -1 to 1 is what's known as the interval of convergence. An interval of convergence is the interval of values for a variable in an infinite series on which the infinite series converges. And this is a concept, the concept of the interval of convergence, that we will talk about much more later on in this unit. All right? All right. So next, where does this formula for the sum of an infinite series come from? Once I know that it is an infinite series. So let's let S represent the sum. S is equal to the list of all of these terms, A plus AR plus AR squared plus AR cubed, etc. Okay, so that's what our sum is equal to. Now, if we do a little, tricky arithmetic algebra here, if I divide this whole expression by R, it gives me this, since this is an infinite series. Now you'll notice that this expression right here is identical to the sum of the series. And so I can replace that with an S. And so this is equal to S. And we get that expression. All right. Now, if I multiply both sides of this equation, we just got done dividing by R. I'm going to go ahead and multiply this back by R. And if I multiply both sides of this equation by R, I get S equals A plus SR. And now, if I subtract SR from both sides, gives me this relationship. I can factor out an S and divide both sides to get S by itself. And boom. There's where our formula comes from. Okay, and that holds any time that R is the absolute value of R is less than 1. All right, so there's where that comes from. All right, let's go ahead and we'll start working our way through some examples of determining whether the series converges or diverges, and if it converges, finding its sum. So, first series, -3 plus 12/5 minus 48/25 plus 192 over 125, etc., etc. First thing I want to do is confirm that this is a geometric series. So I'm going to first find the R value. To get the R value, if you look at this, you can kind of see that in order to get -3 to turn into 12/5, we need to multiply by -4/5. So if this is geometric, that is our R value. And we got that by figuring out what we needed to multiply by -3 to get 12/5. Like I said on the previous page, if you're ever stuck and you want to find the R value, R is always going to be equal to the second term divided by the first term. If we do that division, it's going to give us the R value that we need to see if that's, used to see if this is a geometric series. Now note, if we multiply 12/5 by -4/5, it gives us the next term. And if we multiply that by -4/5, it gives us the next term. So this is clearly a geometric series. All right. Now, first, I want to identify, does this converge? And so I look at the absolute value of R. That's the absolute value of -4/5. Absolute value of -4/5 is less than 1. Therefore, this series converges. And then to find its sum, the sum is equal to A over 1 minus R. A is the first term, so this is going to be -3 over 1 minus -4/5. That turns into -3 divided by 9/5, which is -3 times 5/9, which is -15/9, or -5/3. And so that is going to be the sum of this geometric series when I add them all up. All right, let's go on to part B. First thing we want to do is find the value of r. This one might not be as obvious as the first one was, so it might be a good idea for us to go ahead, if I could write, might be a good idea for us here to take the first term divided by, or pardon me, the second term divided by the first term. And that's -64/125 times 3125/128. And so I've got -64/125 times 3125/128. Oops. And we find that r is wait a second. Did I just type? Oh, that's 625. 625. Whoops. Whoops. I want to change mode anyway here on my calculator. I want to go to exact mode here when I'm doing this computation. And so this is going to be a 625. Now I get that r is equal to -5/2. All right, so the absolute value of r is the absolute value of -5/2. That is greater than 1. Therefore, this geometric series diverges. All right, let's do one more. Part C. All right, so this one is written in summation form, so we kind of have to go through and look at what the terms are going to be and, think about what's going on here. When n is 1, if I substitute 1 in here, I've got as my first term 4.2 times 0.2 to the 0 power. So the first term is going to be 4.2. And then every time we cycle through 1 in this summation, we're multiplying by 0.2. So this is going to be 0.24 is going to be our next term, but that tells us our r value. All right, so r equals 0.2. Absolute value of r is less than 1, which tells us that this converges. And now to find the sum is going to be equal to a over 1 minus r. The first term was 4.2. And the r value is 0.2. So this ends up being 4.2 over 0.8, which is 42 over 8, which is 21 over 4 as our sum. Or if you wanted to write it as a decimal, 5.25. All right, that's where we're going to stop for this video. We'll come back for a second video and finish up example 1 and look at a couple more examples that we have on the page. All right, see you then. Have a great rest of your day, everybody.